Okay, so if we're trying to figure out how to find the distance between 2 points, and if they're graphed, it helps because we can say, okay, I need to find the distance between the point -8, -2, and A, which is at -5, -6. So anytime you have a diagonal line, you can't just count through the grid work because it doesn't work that way. But if we drop a line downward to make a vertical line and then one to make a horizontal line, then we can see that we've just made a special triangle. It's a right triangle. And we can see what the vertical and the horizontal movement was. So horizontally, between the -5 and the -8 is 3 units. And vertically, between the -2 and the -6 is 4 units. And once we have a right triangle, we know something called the Pythagorean Theorem, which says a leg squared and a leg squared added together is the same as the hypotenuse squared. A squared plus b squared is c squared. So in this case, 3 squared and 4 squared gets us our distance squared. We usually call it c, but in this case, let's call it d. Now, it's not 3 plus 4 equals d, it's 3 squared, or 9, and 4 squared, 16. Order of operations matters, we have to square first. 9 and 16 is our distance squared, and since 9 and 16 is 25, the square root of 25, we're trying to get the d by itself, is going to get us 5. So this particular segment has a length of 5 units. Okay, so let's do it again. This time, between A and B, we might go horizontally over here to the 3. We were at 7. We went back to 3. That's 1, 2, 3, 4 units. And moving upwards, we were at -1, and now we're all the way up here at 7. -1 to 7 gave us a total of 8 units. And so once again, we can use that Pythagorean theorem and say 8 squared and 4 squared gets us our distance squared, our hypotenuse squared. So 64 and 16 is 80, and if 80 is d squared, then the square root of 80 would give us a d, and depending on how you want to write this, we could leave it as the square root of 80. It's not simplified. Or we could say 80 is 4 times 20, so 4 times 4 times 5. The square root of 4 times 4 times 5. I have 2 4s here, so we could also call this 4 square roots of 5 if you want to simplify it. Or we could give a decimal equivalent. Square root of 81 is 9, so something close to 9, but not quite, 8 point something. All right, and then same idea. From -7 to +1 is a total of 8 units. And then from -6 to a -1 is a distance of 5 units. And 8 squared and 5 squared gets me d squared. 64 and 25, so square root of 89. So how can we find the distance between them? And when they're graphed, we can find the horizontal and vertical movements. Square those. Add them. And then take the square root. All right, so based on what we noticed, we can do the same thing. This time, though, we don't necessarily have to graph. We could graph A at 2 to the right, 4 up. X movement, Y movement, X is the horizontal, Y is the vertical. And label it with an A, and we could plot 7, 5, 6, halfway between 6 and 8 is 7, 7 over 5 up, halfway between 4 and 6 is 5. So this is 7, 5, this is B. But if we want the distance between these 2 points, the most straightest, most possible distance, we just check out our horizontal movements. The X's are the 2 and 7, so we move 5 horizontally between 2 to 7. And the Y's are 4 and 5, so we moved 1 vertically. And so 5 squared and 1 squared is 25 and 1. So the square root of 26. Picking up some speed here, same idea with number 2. 12, 1 and 0, negative 4. We've moved from 12 to 0, we've moved 12. And from 1 to negative 4, we have moved a total of 5. And so 12 squared is 144. 5 squared is 25. 144 and 25 is 169. So the square root of 169 is 13. That's the distance between those 2 points. And once more, the horizontal movement between the 7 and the 1 is 6. The vertical movement between the 5 and the negative 5. 5 to 0 is 5, to negative 0 to negative 5 is 5 more, so 5 and 5 is 10. So 6 squared is 36, 10 squared is 100, and we would have the square root of 136. So we've seen from the Pythagorean theorem that we can find the distance between points. We can say a squared and b squared is c squared, or distance squared in our case. And if we want to find the distance, we can just take the square root of a squared plus b squared to find that distance. And that's where this formula comes from. Our distance is the difference between the x's, meaning the horizontal movement, squared, and the distance between the y's, the vertical movement, squared. So you've likely seen that in Algebra 1, and it's a big, cumbersome, confusing, crazy formula, right? But you don't have to make it so difficult. It also helps to learn order of operations, so there's nothing wrong with using that formula. But if you see that you need to find the distance between A and B, and remember that when we say AB with no symbol on top, no segment, no line segment on top, or no line on top, then it's the distance between A and B. If we need to find that distance between them, we need to know how much do we move horizontally. Well, the x's, the changes in the x's is between 3 and negative 4. So 3 all the way down to 0 is 3, and then from 0 to negative 4 is 4 more. So a total of 7 units was the horizontal movement. And the vertical movement, because we went from 9 down to 1, we've moved 8. So we're going to square those two numbers, then add them, and then take the square root. 49 and 64, and we would get 113 if my mental math is correct, and the square root of 113 would be our answer. Not 113, that's way too much, but the square root of 113. And so there's a few more problems for you to finish off to make sure that you've figured it out.